All right, guys, this is the review for quiz 7. Make sure you have a piece of paper to do your work on. All right, here we go. We have a ruler. How long is that line? Go. Well, if you look at this line right here, it goes from here over to here. It's lined up with the end of the ruler. That is 1 1/4 inches. So you should have said 1 1/4 inch. Remember, this line here in the middle is the 1/2 inch. These are quarters, so 1/4, 3/4. These are eighths, and then the small ones are sixteenths. All right, here we go. We have a metric ruler. I want you to tell me how long this line is in centimeters. Go. Well, here's 1 centimeter, 2 centimeters, and then we count 1, 2, 3. It goes over the third spot, so that's 2.3 centimeters. Now, I want you to tell me how long that line is in millimeters. Go. Well, each centimeter has 10 millimeters, so that's 1023 millimeters. Make sure you have the appropriate label. All right, how many possible triangles can be created with the angles 24 degrees, 96 degrees, and 60 degrees? Go. Well, if you add these three together, you get 180 degrees. So that can form a triangle. Now, here's the story. These three angles can be a small triangle, a large triangle. We can make the sides any lengths we want as long as they have these three angles. So there are many triangles that can have these angle measures. How many possible triangles can be created with two sides that are 3 inches and 5 inches and a 40-degree angle in between them? Go. That will be exactly one triangle. 3 inches and 5 inches with a 40-degree angle. That sets everything else. There's only one. 6. How many possible triangles can be created with two sides of 3 inches and 5 inches and a 40-degree angle not in between them? Go. Well, there would be two, because we could have a 3-inch side here and a 5-inch side here. And then the 40-degree angle here would make one triangle. If I put the 40-degree angle here, it would make a different triangle. So there are two possible triangles that can be created with those possibilities. Okay, what is the measure of this angle? Go. Well, we have the protractor lined up right where it needs to be. And if I look right up here, that is 54 degrees. Make sure you're using the inside of the protractor because this is an acute angle. If this angle stretched over here, then we would use also the inside, but we would use the angles that are bigger than 90. Which one of these cannot form a triangle? Go. Well, this is triangle inequality. So triangle inequality says we take our first two sides, we add them. 4 plus 5 is 9, and subtract them. 5 minus 4 is 1. So our third side has to be between 1 and 9. So this is between 1 and 9, so yes, that's a triangle. This is not between 1 and 9, so this is not a triangle. This is between 1 and 9, so it is a triangle. So you should have said B is the one that cannot form a triangle. 9. Which one does not form a triangle? Go. Well, we know that the angles in a triangle always have to add up to 180. If I add these three, I get 180. If I add these three, I get 180. So that is a triangle. If I add these three, I get 181 degrees. So this C is not a triangle. All right, now we have parallel lines cut by a transversal. What are angles 4 and 5 called? What is that angle pair called? Go. Well, you should have said that these are alternate interior. They're alternate interior angles. They're both on the inside of the parallel lines and they're on opposite sides. Number 11, what are angles 1 and 5 called? 1 and 5. Go. Well, you should have said that these are corresponding angles. They are in the same spot, upper left of this clump and upper left of this clump. Those are corresponding angles. All right, let me know if you need any more help on any of these concepts.